Recording. So the intention today is sort of a guided review session through the practice test, and as the person who writes the tests, I'm going to try to provide a little bit more insight into why the right answers are right, why the wrong answers are wrong, and what you might, what these questions were going for, which might be helpful for understanding the intentionality behind the test that is going to be on Thursday. As an update about where we are with developing the test, I thought I was going to have the test finished late last night. And then I realized at the last minute that the question I'd been working on didn't work for some reason. And so I have an idea for how to finish it this morning, but I'm hoping to have the test finished and out to the other instructors maybe around 1 or 2 p.m. today, and then I'll be able to give you an update about the length of the test. And it's looking to be about 4 questions long, like 4 pages of questions long. Before we begin, are there any questions? Okay. At any point, feel free to ask questions. Yeah, that would be good. Okay, so this first question here is really a chapter 1 question about the when, where, why, how, who, what of the data. And what we're really trying to get here is these key terms. Now, I'm not a big, as I've probably mentioned before, I'm not like a massive fan of these terms about the who, what, where, when, why, and how of the data. It's really just there to get you to think about data in a more holistic way. And I find that some of these terms are somewhat limiting. When we talk about who was measured, we're really just saying sort of what is the observational unit on which the data were collected from. So in this problem, a survey of cars in a parking lot was used to record the car's brand, country of origin, type of car, and age. So the who being measured, it's a survey of cars. The cars are the thing that we're going and collecting data from, so that would be the who. What was measured, so this is really about the individuals. What was being measured is really a question about the variables. What variables were we collecting data about? And they recorded the brand, country, type, age. So brand, country, type of age, and type of car and age. Okay. So then where were the measurements taken? These questions, the where, why, when, and how, don't have a lot of relevance at this point in the semester for us in terms of statistics. But as we move through the semester and we start talking about generalizing from a sample to a population, the idea that the data we have is representative of some larger population is going to be really important. And so at this point, the where, the why, the when, the how they don't seem as important, but in the real world, having a rich perspective on the data that is going to be quite important. So this is really just trying to get you to think about that. So where were they taken? At a large university. At a large university. And then lastly, why were they taken? Well, sometimes you're just simply not told this information. The information is not given. When were they taken? Again, not given. And how were they taken? They did a survey in a parking lot. And that's not even really that specific. How did they do random sampling? Did they do a census? Did they do some sort of stratified sampling? It's not clear at all what that is, but it's something. It's something we can go on. And so a survey in the parking lot. Okay. Then we're asked to give for each variable, whether it's categorical or quantitative, brand, country, and type are all categorical variables. They are all variables that we would express with words or code, some sort of numeric code that maps onto words. Age is a quantitative variable. Remember, quantitative variables are ones where it makes sense to talk about the average. So it makes sense to talk about the average age of cars in this parking lot, but it doesn't make sense to talk about the average brand or the average country or the average type of car. Those are not averaging types or averaging brands, just simply doesn't make sense from a statistics point of view. Okay. Were there any questions on that first one? Okay, great. I would say that it would be, I think it would be unlikely to have a full question on chapter 1 on this test that is coming up. I just don't think that it's, yeah, I think it would be unlikely to see that. Okay. So the frequencies of traffic fatalities on non-occupants of vehicles are shown in the bar chart to the right. Changes to a bar chart of relative frequencies. Now, when we say relative frequencies, this is to distinguish from the frequency here. These words are somewhat opaque. A friendlier word for frequency is count, and a friendlier word for relative frequencies is percent or proportion. Frequency and relative frequency are a good pairing for each other, but when we're talking about them as just graphs to show people, count and percent are probably better labels than frequency and relative frequency. Now, the key thing to note with a relative frequency bar graph is that the relationship of the bars to each other doesn't change. Whatever percentage this one is, I mean, so 4144 plus 848 plus 290, it's 5282, 4144 divided by that, 78%. This cyan colored bar is 78% of represents 78% of the observations. The cyan bar in the relative frequency one is also going to be 78%. The pattern or relationship of the bars to each other doesn't change. We really don't have to do any mathematics on this problem. All we're looking for is, okay, do the bars look the same in A? No. The brown is too high, green is too low, cyan is too low. Cyan is wrong, green is okay, red is wrong. Wrong, wrong, wrong. Hey, look at that. That's the correct answer. It's really just a change in what it's a re-representation of the labels. It doesn't change anything about the actual underlying data. Switching from frequencies to relative frequencies, from counts to percents, doesn't change the relationships we're seeing. Okay, so a certain country has posted data about the population in the language they speak. It's also worth noting that, just as a meta taking thing, the questions on this practice test, and again, this practice test was a real test in 2020. We drew on publisher questions for some of these, and we adapted some, we tweaked some, but some of these are publisher questions. At this point, we write our own questions, and so I think that, especially as we're going through question 3, there's some ambiguity or some not great wording of things, which I would expect you to not see on the real test at this point. We take a lot of care to make sure that we write the questions so they are clear and understandable. Okay, so we have language broken down by provinces. We've got 10 provinces here. We've got English and French in both and neither, and we've got the counts of people in each one in thousands. So we want to know, first off, what percentage of citizens speak only French. And so French only, this out of everybody. And so what we're going to do is 3954 divided by 29,567. That's going to be equal to 0.1337. So it's round to 1 decimal place, and it wants it as a percent. So we're going to have 13.4%. Then what percentage of the citizens speak French? This is what I meant by sort of an unfortunate wording. Speaking French means that you either speak French only or French and English. And so I don't like there to be context knowledge. I mean, both is a pretty standard term, but that's more opaque than I would like for an exam. Okay. So what we have here is, again, out of all of the citizens, we've got this 29,567 in the denominator. And so now we have 3954 plus 5227. And I want to be clear that it's not the reason why we can add here, the reason why this adding is allowed is nobody is in both of these two columns. Nobody speaks only French and at the same time speaks French and English. Either somebody speaks both or they speak only French. Because we have nobody is counted in more than one spot, we can add these. And so what we end up getting is, we do the math on this, 0.3105, which again, rounding to 1 decimal place and expressing as a percentage, 31.1%. Questions so far? The key thing to note here is we're asking for what percent of the citizens. What percent of the citizens, and we're talking about all of the citizens of a country here, which is why that was the denominator here and here. And I'm really harping on that because the next set is what percentage of province E residents speak French. And so what we're talking about here is only the people who are in province E. So what percentage of, oh, interesting. I actually didn't realize you could change the color of the highlighting. Cute. Of the people in province E, 7122, what percentage of province E residents speak French? Well, again, this idea of speaking French is either French only or both. And so it's these two here, 3834 plus 2906. And this is 0.9464, which expressing as a 1 decimal place percentage, 94.6%. Then we want to know, let's go with a highlighter and switch the color here, what percent of French-speaking citizens live in province E? And so what we're talking about here is we're talking about everybody who speaks French. That's going to be our new denominator. So our denominator here is 3954 plus 5227. And we want to know what percentage live in province E. So that's the two values we already have circled, 3834 plus 2906. Expressing this as a proportion, doing the math on this, 7341, which is about 73.4%. The key thing here is that the denominator is changing. The way people get questions like this wrong is if they get the denominator wrong. That's really what it comes down to, and that's why on a later question I just focus in on the denominator, because that's really the operative thing here. Okay. Any other questions on this one before we move on to the next part of it? So the last part it asks is, do we think that language knowledge and province of residence are independent for this country? So that's a great question about the test. For the test, it is just a single shot at doing the test. And if you do the practice, so that's the only difference between the practice test and the real test that says realistic settings. You could do the practice test as many times as you want, because we want you to get practice with it. The real test, you get a single attempt at it. And usually, especially this first test, scores are usually pretty good on them. And again, if you do poorly on a test, one of the two weighting schemes or systems that we use in this course is gives you a test drop. And so basically for essentially every student, your lowest test is going to be dropped. I think there's only been like 2 or 3 students have seen where the test drop isn't the best grading for them. And the only cases where the dropping a test isn't the best is if a student does very, very well on every single test, or very, very badly on every single test. Those two extremes don't get the benefit of it. But everybody else, your lowest test is dropped. Okay. So when we talk about language knowledge and residence being independent, this is very difficult language for students in an introductory statistics course to wrap their head around. But I really emphasize it because this is a topic that pops up again in Math 2209, and it's a big idea in statistics. And so if language knowledge and province of residence were independent, it would mean that if you told me that somebody spoke French, that would tell me nothing, give me no information to make it more likely that I could guess their province correctly. In Canada, we know that if you pulled a random Canadian out of a hat and said, Doug, this person speaks French. And then you ask me, Doug, do you have a guess as to what province they live in? My first guess would be, well, they probably live in Quebec. Or, the next most likely might be New Brunswick. The fact that there is a greater proportion of French speakers in Quebec, and most French speakers in Canada live in Quebec, that tells me that there's a relationship between province and language. If that was not the case, if the exact same proportion of people in every province spoke French, then it would be independent. I'll answer your question in a second, Alex. So for this question, very clearly, the the proportion of people who speak French is not the same across every province. Just look at this one here, 94.6% of people in province E speak French. For province H, it is 5%. If we were to do 50 divided by 967, that's about 5.2%. Clearly, there's some difference in the distribution of the language across the provinces. So are they independent? Is there really no relationship between them? No, they are dependent or not independent. Or associated. Those are all words we would use to describe this situation. So are they independent? No. And so it's not A and it's not C, because those are yes answers. No, because the percentage of French speakers in each province are not approximately equal, versus they are, because the percentage of French speakers are not approximately equal. Oh, I guess only one of these is no. Okay, so that's the answer. It's no, because the percentage of French speakers in each province is not approximately equal. Okay. So for question D, why did I not divide by 7122 as in the previous in part C? It's because the description of the denominator changed here. We're saying focus in only on province E residents for part C. And so it's this yellow highlighted row. Whereas for the part D, we're saying focus in on only the people who speak French. Focus in on these people in the table and tell me what percentage of them live in province E. Does that answer your question? You're welcome. Okay, so question 4. In 2012, Statistics Canada conducted this survey, and they asked a bunch of households questions about their internet access. And two of the questions they asked are, is there a student in your household, yes or no? And do members of your household access the internet at home using a video game console, yes or no? And they asked a bunch of other questions, such as, do you use a desktop to access the internet? Do you use a laptop to access the internet? And they made a pie chart here. In general, like things like this comment here aren't necessary for the question, but I really like to use real data whenever possible. For tests, I don't exclusively use real data, but I like to use real Canadian data if possible, and if not, real data, and if not, realistic data. And so sometimes I have notes about this so you understand that perhaps it's a simplification, or perhaps there's been a tweak or modification for the purposes of the test. It doesn't really affect anything, but So what we have here is we have this table and we have this pie chart, and we want to know which of the following is an appropriate interpretation to make using this pie graph. Now, right away, we've got a massive problem with this. What is the problem with this pie graph? Yeah, these values don't sum to 100%. Really, what we were asked is each one of these was do you use a desktop to access the internet, yes or no? Do you use a laptop, yes or no? Video game console, yes or no? Smartphone, yes or no? Or other device, yes or no? Any idea what the correct graph for this table should be? There's two correct answers. A bar chart is a very safe answer. Yeah, bar chart is a great answer for this. If somebody really, really liked circles, how would you use a pie chart to graph this table, to represent this table in a graph? Yeah, we would have to have one pie chart for every type of device. We have like desktop computer, it'd be like 60%. We'd have laptop computer, and it'd be a little bit less than 75%. Video game console would be like about a third. This is also about 60%. And here's like 1%. That's the graph that we need. This thing is just a monstrosity that's wrong. The fact that there's not one hole means that this graph should not have been created to begin with. Everything else on it, all of these other answers are wrong because they're meaningless for the purposes of the graph. It's worth noting that desktop and laptop computers account for more than half the people use them each. There's no need to combine them, and it's not an appropriate statement to make from the graph because the graph is a bad graph. It's also worth noting that C is not correct. We can't say this even if this were a correct pie graph. C is wrong because we can't say that almost everybody who used a smartphone also used a desktop and vice versa, because it might be a very different set of people. We simply don't know which 61% of people use a desktop and which 59% use a smartphone. Maybe there's a lot of overlap. Maybe there's very little overlap. We don't have information about the overlap in the people from this table. We just don't have that information. And we couldn't have that information from the table, regardless of the graph that was made. Just because the other category is small does not mean it should be excluded, especially if you have a whole. You need every part of the whole to be represented. If you have several small categories, you might consider combining them into a larger category of like other or like big other. I don't know what you would call it. But you shouldn't just drop it from the graph just because it's small. And then E is not correct because, so looking at this graph, if this were correct, none of these pieces of the graph are more than half the pie, more than half the circle. But again, the graph is wrong. 3 of the 5 device types were used by more than half of the respondents. The key takeaway with this graph was it just simply should not have been made. Okay. Then we have a bar graph summarizing the proportion of households with students in them, just yes versus no. And we want to know which of the following is an appropriate interpretation for this. let's look at D first. The bar chart is incorrect because it should have vertical bars, not horizontal. No, not necessary. Bar graphs can be horizontal or they can be vertical. It's really just a stylistic preference. Sometimes there are some advantages of one over the other, but that's really just a style or preference thing. It doesn't make it correct, incorrect to do one way or the other. So not D. A bar graph should not have been created for this type of variable. We can always make bar graphs for a categorical variable. The large difference in bar heights means that the variables are associated or not independent. We don't talk about association within a single variable like this. Association is about having two variables, and we only have a graph for one variable. And so with this is a distractor trying to get at the idea that if you had two bar graphs you were looking at, comparing the heights of bars is an appropriate way to look for association or independence, as long as you're comparing the right pairs of bars. But in this case, we shouldn't be comparing them in that way, because it doesn't make sense to talk about independence within a single variable. Households surveyed were equally likely to have a student as to not have a student. That means 50% have and 50% don't have a student. And that's not the case. It's very clearly not 50-50. And so more than half the households surveyed did not have a student. And this is the halfway mark. More than half did not have a student. That's true. It's not a particularly, revelatory statement, but it's a true statement and something we can see from this bar graph. The last four questions go for this part get at the idea of the denominator, the same thing we were looking at earlier with the provinces and the language. So when we talk about the marginal distribution of student in the household, which is the percentage of households with or without a student, we're talking about summing these, and we should have, it should be 903, and this should be 3765. We want to know what percentage of the people in the study had a yes student and what percentage had a no student. 903 divided by the sum of these two. The denominator here, if we want to actually do this computation, 903 divided by 903 plus 3765, which is 4668. That's everybody in the study. Then for marginal distribution of video game access, what we're summing across here now, we're summing across these. We still use 4668 because that's the total number of people in the study. For the marginal distributions, we sum across the rows or the columns, and then we divide by the overall total. When we have conditional distributions is where we start to get into a denominator that's specific to that distribution. So when we want the conditional distribution of access using a video game console, given that yes, there was a student in the household, what we're saying is focus in only on the yes people. Yes, there was a student in the household. And so of these 903 people, what percent used a video game console and what percent did not use a video game console? It's that 903 is the denominator there. It's That's the total number that had a student. And then finally, what denominator should be used for the conditional distribution of student given that a video game console was not used to access the internet? Well, we're going to sum across those and get 3494. Any questions on this one before we go on to the next question? Okay, great. Okay, so the next question here is, now this question, question 5, is longer than I would put on the test. This one has far more computations than I think would be appropriate for a test question. So we want the marginal distribution of blood pressure here, and tells us the blanks to fill in. So what we're going to do is we're going to do 97 divided by 482, 97 divided by 482, which is 20.1%. We're going to do 236 divided by 482, which is 49.0%, and 149 divided by 482, which is 3.9%. So again, we're just using that overall total for the marginal distribution. Then we want the 3 conditional distributions, and this is where it gets to be more complicated. So what we're going to do is we're going to divide each one of these by 98, each one of these by 184, and each one of these by 200. And that's really just 9 tedious divisions now. And these are the values we get. So it's really just using these totals there. Then we want to talk about, give some kind of description of the association between age and blood pressure. Now, when we're looking at this, it may not be clear what we should be looking for. Notice that the normal blood pressure percentage is about the same for all 3 age groups. About half of the people in each age group have normal blood pressure. But let's compare under 30 to over 50. 10 percentage points fewer over 50s have low blood pressure, while 15 percentage points higher have high blood pressure. It seems like the relationship is that, and the 30 to 49 group is sort of in the middle of this. As employees are older, they tend to have more high blood pressure. That's really what we're seeing here. Now, based solely on this table, based solely on these values, we don't know what this means. We don't know that we don't get to say that people with low blood pressure get high blood pressure later, or people with low blood pressure get normal, and normal blood pressure will become high. We don't really we can't talk specifically about what is causing us to see this relationship, but we can say there is a tendency for older employees to have higher blood pressure than younger employees. Any other questions on this one before we go to the last question? Okay. So for question 6, this is based on real data from 2020. This market research firm asked 2 questions. We want to compare the agrees and disagree and did not agrees for these questions. So, are changes needed to ensure a consistent and high level of care is provided to all long-term care facilities, public and private, and is increased staffing needed in long-term care facilities in my province? We want to determine if there is an association between the response to the question and the provinces that people live in. So what we're seeing here is we're seeing the responses, the agrees and do not agrees, broken down by the province. And so we've got BC here and BC here for the 2 questions. We've got Atlantic Canada here, and we've got Atlantic Canada here. Without more formal methods, it's not clear that we could definitively say whether there is or is not an association in each one of these 2 questions separately. If I only gave you one of these graphs, that's a much harder question relative to the tools you have. You really need Math 2209 tools to answer that. But what we can say here is there seems like there's more evidence of an association between the region and the response for one of these 2 graphs. One of these 2 graphs is closer to looking like there is an association. Which one of these 2 graphs is it and why? And what we're doing here is within each one of these graphs, to check for an association, we're looking to compare similar bars. So we want to compare the heights of the agrees in this one. If we see all of the bar heights that match as approximately the same, that's suggesting independence, no association. It does not matter what province people are in, their responses tend to be the same. Whereas here, it seems like there's a bigger difference in the heights of the bars. There's more variation in the heights of the bars. For Quebec is here. Compare Quebec and BC, or Quebec and Alberta, or prairies, I guess is what it is. Let me just erase this here. For Quebec and Alberta, it seems like there's actual differences in the heights of the bars. This bar here is at a much lower level, whereas this bar here is at a much higher level than that one. Those differences in the bars are more extreme for the graph on the right. That means there is more evidence of an association. And so this is sort of like the model sample answer, where you should say that there is stronger evidence of an association for question 2, And the reason why we can say that is the bar heights for the agrees are all approximately the same height in question 1. They are less approximately the same for question 2. That's really the key thing here. Now we can't definitively say for sure whether there is or is not an association, but there's more evidence of one for question 2. Any questions on this? Yeah, Alex, what's up? I can't hear you if you're talking.
Hi, can you hear me?
Now I can, yes.
Sorry about that. I forgot to turn on my mic. I just wanted to confirm that the way you were able to get the answer alone was kind of just by comparing the bar heights. There was no additional, like I didn't miss anything.
Correct. That's really we're just looking at comparing, making appropriate comparisons within the graphs, and
Okay.
so that can either be focus on comparing this agree to this agree, this agree to this agree, and comparing all the agrees and then all the disagrees, or it can be looking at comparing the gaps between them. So like, is the gap from here to here the same as the gap from here to here, which is the same as the gap from here to here? As long as you're making the same comparison, that's fine. What does not tell us anything about association or independence is the fact that the purple bars are much higher than the orange bars. That doesn't really matter at all, whether they're all approximately 50%, or one of them is approximately 90%, the other one's approximately 10%. It doesn't matter as long as it's consistent across the same like matching categories. I think that is the end of the review. I'm going to stop the recording and then answer any other questions you might have about the test or how the logistics of it work. And then that's probably it for today, and I will go back to finishing the test.